All right, good afternoon, everybody. We're going to talk about kind of the part two of this fundamental theorem of algebra, but really this part two is just me working four different problems here, and so you kind of just get through, see just more opportunities to learn this concept. Now, understand that we are taking the fundamental theorem of algebra and kind of applying some different things. We're going to use that as the basis for giving a rough sketch of graphs of higher degrees. So when we get into these higher degrees like 6, 8, 7, and 5. They're very difficult to graph because they get so large very quickly, but we can kind of generate some ideas of what it might look like just based on the information I give you here. All right, so let's just kind of break this down. This is going to be kind of a rather short video. Recommend that you might pause the video for just a second and then see if you can just do all these on your piece of paper and then see if you compare with mine. All right, so the first thing I want to do is imaginary solutions. So notice that there's 4 real solutions and 6. It's a 6 degree, so there's 6 solutions. So I know that there are going to be 2 imaginary solutions. Now, by knowing that, that does work because remember, imaginary solutions always come in pairs. And also, leading coefficient is negative, okay? So it's going to end going in this direction, okay? And also, the thing we learned yesterday, and people made comments about, was that because this is an even number, I know that it's also going to kind of start from below, okay? So it's going to come up this way. So I know this is my starting point and this is my end point. Now what happens in between is what this information gives us. So let's take a look at this. I know that it has 4 real solutions, which means it crosses the x-axis at 4 points. All right, so if I do that, 1, 2, 3, 4. I also know that it has one less critical points, 1 less than a degree, so I need 5 critical points. And you'll notice that 1, 2, 3, I need 2 more critical points, which hopefully by now you guys are catching on that all you need to do is just put another line there, okay? Now again, you might have a little different drawing than mine, but that's okay. That's fine. Relative maxes, 1, 2, 3, so there are 3 relative maximums. There are 1, 2 relative minimums. And then absolute maximum minimums, this is kind of a gray area depending on how you draw the graph. We know that there are going to be absolute maximum minimums because it is an even degree function. And so we have, in this case, I kind of drew these about the same height here. So in this particular graph, I have 2, but I could easily kind of extend that out. Like, let's say, for example, that let me erase this real quick. Let's say, for example, I redraw these a little bit and I say, let's say this one's just here, and then this one goes up a little higher. Then in that case, I would say I have 1 absolute value and this would just be a relative maximum, or an absolute maximum here. This would be an absolute maximum, highest point. All right. So the next thing we're going to do is graph this one. So again, I'm going to walk through this particular problem here. We know it's a degree 7. It has 3 real solutions, which makes it have 4 imaginary solutions, so I know I'm okay in that area. We know that it's going to end positive, so it's going to end going up here, and because it is an odd degree, we know it's going to start here. Okay, so in between this little section here, I need to graph all this information. So we know it crosses the x-axis at 3 points. So let me get that going here. 1, 2, 3. And then I also know I need a total of 6 critical points, okay? Because remember, it's always 1 less than a degree, so I have instead of just putting 1 turn in there, I have to put 2 of them in there, because now I have 1, 2, 3, 4, 5, 6. That makes 6 critical points, so that's good. And relative maximums, I have 1, 2, 3 relative maximums, and I have 1, 2, 3 relative minimums. Whoops, whoa, getting a little crazy here. And then you'll notice that there are 0 absolute maximum minimums, meaning that there is no high point or low point in this particular case because it is an odd degree polynomial. Okay, so that's going to tell you that it's automatically 0 on absolute value. I'm going to work these rather quickly here, so pay close attention here. It's a degree 8, so I know, and it's positive, so I know it's going to end this way. And because this is even, it's also going to end going that way. It has 4 real solutions, so 1, 2, 3, 4. I know my graph has to go through that, so I'm going to start that little way there. And then I need to put in, well, let's see, 4 imaginary solutions because of the fact that I need to make up those other solutions. So we have 1, 2, 3, 4. And you'll notice that I have how many relative maximums? Let's see, 1, 2, 3, 3 relative maximums, and I have 1, 2, 3, 4 relative minimums. And then we also know how many absolute maximum we have. Again, I kind of drew them rather close together, but we know we're going to have absolute maximum and minimums because this is an even degree, and so I could say, in this case, they look about even, so I'll say 2. I got to make sure I get that on the next one here. All right, so the final one here is a degree 5 polynomial. Leading coefficient is positive. All right, let's see, that means it ends here. It has 4 solutions, so 1, 2, 3, 4. And so if I do this one, uh-oh. I see a problem here because of the fact that I've gone through my 4 solutions, and the only way to finish up here, and I have to because the leading coefficient is positive, I have to go through the x-axis again, which would not work, okay, because I have already clarified I only have 4 real solutions. Hence, I come to the problem that you might have noticed at the start, which is the idea, well, I have 4 real solutions, so that means I have to have 1 imaginary, but that does not work, okay? Does not work because I have to have imaginary numbers come in pairs. Okay, so that does not work, having a 1 as imaginary solution. So this problem is not going to work because I cannot get back up through to get to this endpoint without going through the x-axis again, which would void the information I gave you. All right, so hopefully this video helped out, prepare you for tomorrow, and I will see you tomorrow. Thank you.